This should be vocab you've seen before, but if you haven't, here's your chance to get it. So far, we've talked about a function as a rule that connects two groups. And the first group, the inputs, come from what we call the domain. Then it goes through the function, and we get out the values in the range. Generally, these are our x's, and these are our y's. So the x values go in, the y values come out. And the function is whatever rule we use to connect those values up. Now there's another bit of vocab we're going to talk about called the independent variable. And the dependent variable. You'll also see the independent variable referred to as the control variable. It's the one I have control over. It's the one I can modify. And then I want to see what comes out, what depends on that. And so the first task, as we start working into coming up with these functional rules, which is one of the major goals of Chapter 4, is if I give you a set of data and say, here's some numbers, do stuff with it. One of the things you have to do is come up with a rule that connects the independent variable to the dependent, that find the pattern between the x's and the y's. Take numbers out of the domain and assign them to values in the range, and then make predictions from it. That's really the ultimate goal we're going for with this. So let's say I talk about doing a study. So I'm going to do a study, and I'm going to look at test scores, and we'll keep it simple and obvious, and the time spent studying. Which is the independent variable versus the dependent variable? So I think about this. Which one is going to determine the other? Which of these two values I'm going to get back in number form? So I'm going to take all you guys out. We're going to look at all of your grades. So we'll get that big pile of numbers. And I'm going to ask you how long did you study? I'll have all that big pile of numbers. Which one depends on the other? Let's start with okay. Let's start with the idea of the dependent variable. Which of the two collections of numbers, your test scores or the time you spent studying, is more likely to be dependent on something else? Test scores? And then study would be the independent. That kind of what makes some sense. We want to see if the longer you study, how that controls what your test score is. We can also, we do an experiment. I can take one of you in particular. I can say, all right, actually, here's the plan. You're going to study for 1 hour for this test. And then for the next session, you're going to study for 3 hours. For the next session, you're going to study for 5 hours. And we're going to see what happens to your test scores. And see if they go up or down. We can control how long you study. We can just put a little egg timer. When the timer goes off, you close your book, walk away. We can control it. Generally speaking, that's one of the ways to know you're talking about an independent variable. You have direct control over it, which gets back to that control concept. Do another example. Let's see, what else can we look at? Hours worked and money made. Doesn't mean you worked, well, I'll put the assumptions in there later. The independent is your input, independent in, dependent is what you get out. Yeah. So, keeping with that mindset then, which of these is the independent variable? Hours worked or money made? That's my independent. I can control that, sort of. And the money made, the dependent. That's pretty much I get my paycheck and I go from there. Now this only applies if you work an hourly job, of course. Some jobs are based on salary, and no matter how many hours you work, you get paid the same amount of money. You know, if I show up at 7 o'clock and leave at 2, or if I show up at 6 and leave at 5, I get paid the same from salary. I don't get paid hourly. Which makes me wonder sometimes why I show up at 6 and stay till 5. That's not true. I do it because I love you guys. I'm recording this. I want your parents to hear it. It makes me look good. All right. Let's grab one more of these just to be sure we got the basic idea down. I should do something a little bit varied here, though, because I'm being consistent. And, value of a stock and the number of stocks sold. We'll do a hard one here. And we'll stay in this concept of bringing in real-world examples. So which one is independent, which one is dependent? Which would be my input into a rule that I'm going to use to predict things? Which would be my output from that rule I'm going to use to predict things? Remember, the goal of a function is to come up with a rule that will help me predict one or the other based on the first. What's your guess? Value of stock is the what? Independent. And the number is dependent? Why? So if it's cheap, I'll sell more. So the price drives, let me write this down. So if you say price drives sales, then value is my independent, number is my dependent. And that's true. As the stock price goes down, people tend to, depending on what kind of stock it is, they start to buy it up because it's a bargain, or they sell it off because the stock's going down. They're trying to get rid of it. Why? Because it must be popular. If you say sales drives price, then the value becomes my dependent variable, and the number sold is my independent. And you know, what's interesting with stocks, and most commodities, it goes both ways. Things that are, let's talk about this example here. I input the number sold. So I tell you, I cannot keep the iPad on the shelf. I run a little boutique where I sell electronic goods, and every time an iPad comes in, it walks out the door no faster than I can unwrap it. Some of them are still bubble wrapped. What does that tell you about the value of these devices? They actually charge you more, probably. So I'll slap a couple of surcharges on it. Yeah, well, they're already $4.50. So they can go up to $6, depending on what kind of bells and whistles you get. You can get them as cheap as $4.50, but that has like nothing interesting on it. But in some ways, philosophically, both of these are true. It's all about understanding the pretext, understanding the idea of what's the input, what's the output, what controls the other. More than likely, you're going to see these examples on a test or a quiz. So let me give you a couple more tips to round this out, and then we'll move on to the next big idea. Specifically, let's talk about some tips. I want to talk about get this up so I can see it here, common independent variables. Time. I can control how long I do something. So time is almost always going to be in that independent variable area. Also, we tend to talk about a number of items. Now, it's not always the independent, but a lot of times we'll say there's a cost per car, or you make so much money per book. That makes the book the independent variable, so I can control how many books I sell. Sort of. Common dependent variables. Money made. It's almost always going to be a dependent variable. Not always, almost always. For example, we could talk about how much money you make versus how many cars you own. The more money you make, that will control or determine how many cars you have. So you can change it around. But generally speaking, if we talk about money, we're looking at something along those lines. Yeah.
So like, I'm not too sure, but is it dependent variable on the product that you like find out?
Right. It's the result. This is what I put into the function, the independent. I get out my dependent variable. I get my product. I get my result.